All right, welcome back to Genius. So let's talk about the math module. Okay. So now, in as much as we have not really discussed what modules are in Python, but the math module is like a library that Python has written. And in that library, they have different types of functions that could help us to do a lot of math easily. So I'm not going to go into what modules are, but just understand that this math module that we are going to be talking about here is like it's like a file or it's like a library that Python has a lot of functions in it that we can use. So Python math module is in Python, it provides access to advanced mathematical functions and constants beyond basic arithmetic. So whenever you want to perform advanced mathematical operations or mathematical functions or constants, you can actually use this math module. And this is one of the reasons why Python is very, very good when you want to build scientific applications in data science, in AI, engineering, finance, game development, scientific computing. This is the reason why Python is very good because Python has a lot of these modules. Don't worry, we're still going to discuss what modules are later on, but these are functions that Python has written, and it came when the time you installed Python, these modules came with it. Okay, so the math module is a built-in Python library. Okay, don't worry, as we go on, you're going to understand what we mean by library and module. Okay, it works with real numbers. It provides high precision mathematical operations. It's optimized and it is written in C, making it fast and reliable. Now, C is another programming language. Okay. Now, Python is slower than C. You might not understand this thing, but it's just okay. Let me forget about that because this is not beginners level thing. Okay, but most of the Python code or most of the Python library that we are using, they are written in C. Okay, and then because C is a faster programming language than Python. All right. So the math module does not support complex numbers. It supports the normal integers and floats. It doesn't support complex numbers. And even complex numbers are actually beyond the scope of this our program. Okay. So for complex numbers, Python provides a C math module, but that's not what we are talking about. We are not working with the complex numbers. We're only working with integers and floats. So if you want to use this Python, if you want to use this math module, what do? You would import it because it is not available in your source code. You have to import it. So how do you import it? You say import math. Now let me open my IDLE. So if you're using Visual Studio Code, fine. If you're using PyDroid, fine. Okay, both of them, it works as long as you have installed Python. So if I want to make use of this math module, I have to tell Python to import it for me using this, writing this statement import math. So whenever you do this import math, Python knows exactly what to do. It will import it for you. Okay. So that if you want to make use of any of the functions that are available in this math module, you have to import math like this. Okay. So, or if you're very sure of some of the functions that you want to use, you can also you can also say from math import square or pi. Now this is somehow advanced because we have not talked about module. It could be confusing. So I can say instead of say import math, I can say from math import square root. So I can now go on and use this square root method. I can use this square root method. I can say, what is square root of 8? Does 8 have square root? No, square root of 16. Okay, square root of 16. It will give me the square root right away, 4.0. So, but you can, for now, all right, just forget about this other way. If you want to make use of this math, just do import. All right, import math. And now, if I want to make use of that square root method, I will now say math dot square root. So that's just the difference. But for now, please stick to the second one I'm using now, this import math dot square root. Okay, stick to this. This will be easier for you. Forget about the first one. It could be more advanced. You might not understand what we are doing there until we talk about modules. Okay. So Now, let's take a look at some of the constants that are available in this math module. We have the pi. So if you want to get, pi, um, the value of pi does not change. That is why it's a constant. So whenever we are writing a Python code, any value that you're very sure that it wouldn't change, you have to make it a constant. Don't worry, as we grow, you would understand more. So, but these are some of the constants that are available in the math module. We have the pi, we have the Euler's number, we have the tau, we have the infinity, we have the not a number. Okay, so whenever you find, of course, I doubt it that you're going to be making use of any of this right now. The one you could be making use of is the pi. So in case you want to make use of the pi, you use this actually a constant in the math module. So basically for me, I don't think I use this thing often. I don't. Okay. So but if I want to get the math.py, I will say math.py like this, and it will give me this constant. If I want to say math dot the Euler number, it gives me the number. Okay, math dot tau, it gives me the 2 pi, as in, I don't, the thing is that, it's been a long time I did this mathematics, but for you guys that are still fresh from secondary school, you're still in the university, most of these things could be, you will relate to them. I've forgotten what they call this, sorry, this one, this math.tau, this, I've forgotten what they call, but I know I can actually recall we use it a lot. So the infinity, the not a number, don't worry, as you go you would understand better. Okay, so if you want to make use of those constants, you can. So import the math. So let's assume now, what's that formula again that we use pi? I've forgotten. I've forgotten that formula that we make use of pi. Okay, so but whenever you are doing a mathematical operation, or you're writing any mathematical function, and you want to make use of pi, you don't have to remember the value. You can just come and use the math module and say math.pi to give it to you. Math.e, math.infinity, math dot not a number. So we also have the square root. You have already seen me do the square root. We have square root. So if you want to make the square root of a number, you actually say math dot square root, SQRT. All right. If you want to get the power of a number, you can say math dot power. So this I can go on and say math dot POW, that's power. And then I want to raise 2 to the power of 8. All right, and it will give me 256. So you have seen square root, you have seen power, you have seen the constants. Okay, there are a couple of them here. So the difference is that you can also use, instead of, we also have the power, even without the math.power, we also have the power, but you can say 2 raised to power 8. It would also give us the same thing. But you can see now that the normal power function returns an integer, while math.power returns a floating number. I can also say 2 exponential 8 like this. Oh, sorry, I have a space there. I can say 2 exponential 8. It will still give me 256. So there are different ways you can actually do this power. Okay, so if you use the power method, the power function, it will give you an integer, to return an integer. But if you use the math.power, it will return a floating number. And if you also do the exponential 2 double asterisk 8, it will still give you an integer value. Okay, that's the difference. So the double asterisk, the exponential operator returns the exact type, while math the power returns a float. So you can also have the cube root from Python 3.11 and above. There is the cube root. So I can say math.cube root. So the cube root of 27, if I want to get the cube root of any number, if I say math.27 CBRT cube root, all right, cube root of 27 will give us 3. So because 3 times 3 times 3 will give us 27. Math dot cube root of 81 is 9 times 9. 81 times 9 will give us what? 89 times 9 will give us, I've forgotten. Okay, so but you can use it to this thing to get the cube root. So cube root of 8 will give us 2 because 2 times 2 times 2 will give us 8. So cube root of 8 will give us 2. So but anything, most of the things in this math module, most of the functions, they return floating numbers. Okay. So we have the, if you want to round, if you want to do some rounding up or approximation, you can say math.ceiling, math.floor, math.truncate, math, we also have the round. So now math.ceiling will round it up. So if I go on and have something like, I have, I say math.ceil, okay, and I have 6.7. 6.7, approximation of it to the ceiling will give us 7 because we are approximating it to the ceiling. We are rounding it up to the next whole number, which is 7. Math dot floor will return it. If I say 6.7, all right, it will reduce it to the lowest integer, which is 6. So math.ceiling will take it to the ceiling, math.floor will reduce it to the floor. Okay, so you can also say, what other one do we have here? We have math.truncate. If you want to remove the decimal number, okay, of a floating number, you can say math.trunc, and they want to truncate 7.99. So if you go now, it will give us that because we are removing the truncate method. The trunc method will remove the decimal numbers. Okay, so you can also use math. You can also we also have the round method. If I say round and I say 7.6, it will round it to the nearest whole number. Okay, so these are a couple of rounding and approximation functions. So practice with them. Practice with them. You can see math.ceiling 4.2 will give us 5 because it's rounding it up to the whole number, to the nearest whole, highest whole number. And math.floor reduces it to the floor. 4.9 is truncated to just 4. If you want to round a number, you can also give it the precision. How many numbers, okay, do you want to round it up to? So you can also have we also have the math.fabs. It returns the absolute number, floating absolute number. We have the abs. Okay, we also have the math.fabs. Math.fabs always returns a float. It always returns a float. But abs, okay, or the abs method returns an integer. Abs works with both floats and both integers and complex numbers. So you can use the math.fabs. Math.fabs returns a floating number, the absolute value, but in a floating number, while the abs method or the abs function returns the absolute value. Okay, whether it is integer or float or complex number. If you want to do some factorial, you can also say math.factorial. Factorial of 5 will give you 120. So try it out. All you have to do is the math.factorial. If you want to do combination, you say math.comb, COMB. So all these things, in short, I have forgotten all these things, how to do factorial, how to do combination. You also have permutations. Okay, so if you still remember all these things, if you want to use them, you want to do. Now, if your teacher tells you to do, give you a permutation assignment, you can come and use your Python and import the math and say math.comb or math.permutation. Okay, for me, I've forgotten some of these things. All right, it's been a long time I use them. We also have the math.log. If you want to do the natural logarithm of a number, you can say math.log. X is the base. Okay, math.log 10x, math.log 2, math.exponential. So if you want to perform all these logarithm functions, you can use this. Functions here. So math.log of 10 will give us. Try it out. Math.log 10. Okay. So try all these things out. All right. Try them out. Trigonometric functions. If you want to get the sine, the cosine, the sine, the cosine, and the tangent. I have forgotten all these things. Okay, but if they tell you to get the sign of a number, you can actually use the math.sine, math.cos, the cosine, math.tangent. So math.sine math.pi over 2 will give us 1.0. So just try these things out. Okay. Math.degrees. So um the so if you want to convert degree to radian conversion, you can say math.degree, you give it the radian conversion. The thing is that I have forgotten all of these things, but if you still remember them, please just make use of them. Okay, so math.sin h, hyperbolic functions, math.cos h. So you can see that all those mathematical operations or functions that you perform in mathematics, you can actually use it in Python. And that is why Python is very good in performing in working with scientific applications and stuff like that. So they are used in neural networks and physics. So that is why Python is so good with AI and stuff like that. Euclidean distance, if you want to perform the Euclidean distance, you say math.dist. Okay, you perform this. The reason why I'm not explaining any of these things is because I don't even remember these functions in mathematics anymore. It's been years I did this mathematics, so I don't remember them. But for you, you still remember them. So work it out. The hypotenuse, you can also work it out. Then special floating functions. Ma dot infinite, ma dot is infinite, ma dot is number. So if you want to check if a number is not a number, you use the ma dot is not a number. Somehow these things are advanced, but just work with them. Ma dot is infinite. We'll check if x is an infinite number. Ma dot is not a number. We'll check if s is not a number. So these are examples. So just try them out. Okay. So thank you very much. I'm so sorry I wasn't able to explain because I cannot explain what I don't know or explain what I can't remember anymore. But I believe you guys are still in school. You understand these things. So just play around with those numbers. Okay. I'll see you in the next class. Thank you very much.